There is an unusual psychological allure to Rube Goldberg-like machines. Combine this with an ability to display time based upon the configuration of glass marbles in a device, and the billion-year marble clock is born. Presented here is a billion-year marble clock simulation that includes different timescales, illustrations, and a clock-like chronometer. It summarizes and synthesizes Big Bang cosmological evolution along with historical geology or paleontology. A marble dropping to a lower level marks a factor of 10 going back in time. Each marble that drops onto the second tilting platform goes back in time by 30 seconds times 10, which is 5 minutes. Each marble that drops onto the third tilting platform goes back 5 minutes times 10, which is 50 minutes, and so on. In this way, it reflects the principle of superposition in geology, which is that the deeper one goes into the Earth's subsurface, the further back in time that layer of rock was laid down. The current arrangement of marbles show a time going back to the very beginning of the universe, which is 13.77 billion years. Also shown are 4 different linear timelines of history. Let's start at the present and go back in time to some momentous events that have happened long ago. This button takes us back to the KT mass extinction, where all the non-avian dinosaurs died out suddenly due to a 15-kilometer wide asteroid smashing into the Earth at about 64,000 kilometers per hour, creating a crater about 180 kilometers wide. There is evidence that this initially produced a global firestorm followed by a long winter, where the sun's radiant energy was blocked by ash and soot in the atmosphere, collapsing the food chain. Going back 251 million years takes us to the Permian-Triassic extinction event, or the Great Dying. About 96% of all marine species and 70% of terrestrial vertebrates were killed off suddenly. Our knowledge of exactly what caused this extinction isn't as strong as the KT extinction. Some hypotheses include an asteroid impact, volcanism, massive methane release, and/or a severe depletion of oxygen. The next step takes us back to the beginning of the Phanerozoic Eon, or early Cambrian. This marks a profusion of biomineralizing organisms that left clear fossils in rock layers due to their hardened or stiffened tissue. One has to go all the way back to about 3.7 billion years for the beginning of life on our planet. Very simple life, but life nonetheless. Evidence comes from fossilized microorganisms in hydrothermal vent precipitates. The beginning of the Earth was about 4.54 billion years ago, which is deduced from radiometric age dating of meteorite samples and is consistent with age dating of lunar rock samples and oldest known terrestrial rocks. The next step is one huge leap, reflecting our Earth-centered knowledge bias, taking us back to the beginning of it all, the beginning of the universe. There are multiple pieces of evidence that support that the universe had a beginning. The first strong piece of evidence came from Edwin Hubble's analysis of galactic redshifts, which showed that galaxies were receding at a rate that increased with distance away. And, thinking on this grand scale, there is evidence from observations of distant supernova events of the existence of dark energy, which will cause the universe to expand indefinitely. Closer to home, Earth's long-term future is bleak. a predicament that led Neil deGrasse Tyson to tweet, "In 5 billion years, the sun will expand and engulf our orbit as the charred ember that was once Earth vaporizes. Have a nice day." Yes, the sun will enter a new stage of its life and become a red giant. This marble clock can display a maximum time duration of 100 billion years by clicking here. This simulation allows the users to click and drag, such as scroll, on the various timelines. All the scroll markers in each timeline indicate the same moment in history. We can scroll through the Phanerozoic eon in this timeline. Notice the same mark in time on the plot of marine animal extinction rate as a function of time. This is a key graph displaying the major mass extinctions in Earth's history, which has prompted paleontologists to divide this history into eons, periods, and epochs. As we scroll down, illustrations of life from that time appear. Here's a picture of myself with a reconstructed Dunkleosteus, an armored fish that was quite large and lived during the late Devonian. It grew to about 6 meters long. Scrolling down the Earth history timeline will call up a display of bedrock and its age at different locations in North America. Interspersed in this timeline are significant events transforming the Earth. There is also evidence supporting large-scale global glaciation from 2.4 to 2.1 billion years ago. This is the snowball Earth hypothesis. The great oxygenation of the late Archean, about 2.45 billion years ago, was one such event. Oxygen began to appear in significant amounts in the Earth's atmosphere from cyanobacteria. The Earth in the Hadean eon was pummeled by asteroids in an event called the Late Heavy Bombardment. Evidence also exists that Earth got slammed by an object about the size of Mars. The coalesced fragments of this collision formed Earth and Moon. Notice that this occurred about 4.3 billion years ago, as indicated by 4 marbles on the billion platform and 3 on the 100 million platform. The most coarse timeline is the universe history. Scrolling on this timeline will display a graphic that plots cosmological evolution as indicated by the Big Bang Theory. Notice that it is not a linear plot, it is a logarithmic, meaning that 1 centimeter movement of the white arc in the graphics does not correspond to equal durations of time for 1 centimeter movement on the right and left side. The 1 centimeter movement on the right is much, much longer than 1 centimeter movement on the left. By scrolling on the left side of Universe History Timeline, we'll call up a vertical logarithmic scale showing important stages in the evolution of the universe. Many people ask, what is the universe expanding into? The very question is a misconception. Outside the conical graphics is nothingness. It is not empty space. It is the purest form of nothingness that one can imagine. Experts describe the Big Bang as an explosion of space itself. This puts immense strain on our brain. The vast proportion of history is normal galaxy and stellar evolution, which is what's happening on the present moment. Normal stars began to bathe the universe in visible light about 150 million years since the beginning. From a time marker of 150 million years to 380,000 years from the beginning, the universe was transparent to visible light, such as photons, but devoid of it since the first stars had not yet formed. This is why it is called the Dark Ages. Radio wavelength photons did exist, along with photons from cosmic microwave background radiation, which fills all of space in the universe. These photons had already shifted into the infrared. After about 380,000 years, neutral atoms began to form in what is called recombination. As one continues going back in time, the universe gets hotter and hotter, which implies higher frequency photons and faster moving particles. From 120 to 10 seconds, the Big Bang nucleosynthesis occurred. This is the point in time in which protons and neutrons bonded together via the strong nuclear force to form isotope nuclei of hydrogen and helium, along with trace amounts of lithium. We are now reaching the very fractions of a second since the beginning. Millionths of a second. From 1 second down to a millionth of a second, which is the hadron epoch, quarks began to form hadrons, which are either baryons, composed of 3 quarks, or mesons, composed of 2 quarks. From a millionth of a second, 10 to the minus 12, to about 1 millionth of a second, an extremely hot quark gluon plasma existed. The Large Hadron Collider at CERN and the Relativistic Heavy Ion Collider at Brookhaven have experimentally examined this state of matter energy, where the temperatures are over 1 trillion Kelvin. We are now at the doorsteps of the very beginning. At about 10 to the minus 32 seconds, the universe expanded extremely rapidly, according to inflationary theory, which is part of the Big Bang model. At times of 10 to the minus 44 seconds, an extremely brief amount of time, there are more questions about the nature of things than answers. We are at the very precipice of the beginning of everything. Questions arise. Why is there something as opposed to nothing? Do natural laws exist that govern the nothingness? Was the beginning an initial singularity born out of the quantum properties in a multiverse? Are these questions in the realm of philosophy and not science, since science is founded upon observational evidence, and this may forever remain out of reach of our intellect? This completes our romp through deep time on the order of millions and billions of years. I hope you have found it fascinating. Feel free to continue your time-traveling explorations of the universe and Earth online or at your local library.